container management systems like Kubernetes and Docker Swarm give us a higher level management tool for architectures built out of distributed containers. Container platforms like Rancher provide an even higher level of usability, and today's guest, Darren Shepard of Rancher Labs, takes us through what a container platform is and how it builds on the functionality of a container management system like Kubernetes or Docker Swarm. This interview is part of our continued coverage of Kubernetes and Docker and the other components of the growing container ecosystem, and I always want to know if there's something of this area that I'm missing. I really want to cover this area in depth, so you can always send me emails with suggestions. Some other quick announcements before we get started. The Software Engineering Daily community is working on a project called Software Daily, which was started by Jeff Tribble, a member of the Software Engineering Daily community. We're building an open source news and information site about software, and I think this is a really important project. If you're a web developer who has some spare time and you're working with React.js or Flux architecture or Node.js or really any web technology, check out the Software Daily repo at softwaredaily.com. SoftwareEngineeringDaily.com, which is the website of this podcast, also has some interesting links if you want to check that out. You can sign up for the newsletter, Software Weekly. You can join the Slack channel. You can see my Twitter account or send me an email. You can also find out how to host a show. If you're interested in becoming a host or helping out with the outlines that I prepare for these shows, there are links for that on SoftwareEngineeringDaily.com. And with that, let's get to this episode after a quick message from today's sponsor. If you want to learn about Kubernetes, go to apprenda.com/sedaily. Today, you can find a webinar about Kubernetes, covering microservices, persistence, and multiple clusters. You can also find links to a past webinar covering the history, the origins, and the technical architecture of Kubernetes. The webinars at apprenda.com/sedaily are hosted by Joseph Jacks, a member of the Cloud Native Computing Foundation, who was previously a guest on Software Engineering Daily. If you're looking to move to a cloud-native infrastructure platform that works with your existing apps, you should also check out apprenda.com/sedaily. Apprenda provides cloud platform software that works with your existing applications and infrastructure. So if you're looking to migrate to cloud native, but you want to maintain your existing applications, you might want to check out Kubernetes and Apprenda. Thanks to Apprenda for being a sponsor of Software Engineering Daily. And if you want to learn about Kubernetes while supporting Software Engineering Daily, go to apprenda.com/sedaily. That's APPRENDA.com/sedaily. Thanks again, Apprenda. Darren Shepard is the co-founder and chief architect at Rancher Labs. Darren, welcome to Software Engineering Daily.
Yeah, thanks. I'm glad to be here.
So today we're going to talk about container platforms. So let's start off by just discussing what that terminology actually means. What is a container platform?
Well, that's kind of a really wide description. So we would consider Rancher being a container platform, which would be kind of the full end-to-end solution, which would be storage, networking, app orchestration. So honestly, I think it's bigger than what most people would think of in terms of Kubernetes, Swarm, or Mesos, for example. Most people would think of those as being the complete platform, but those are really like application frameworks or schedulers.
This differentiation between a framework and a framework/scheduler and a container full-fledged platform, could you touch a little more on that?
Right. It's kind of the premise of what we do is for example, let's say you want to run Kubernetes. Kubernetes in and of itself is not really a complete solution. It's designed to have certain plugins, hooks for other things such as like storage and networking. So for example, if you want to run Kubernetes, you might be looking at GKE. It's like, why does GKE exist? Because it adds in a lot more things that you'll need to kind of complete the whole picture.
Sorry, what is GKE?
GKE is the Google Container Engine. So it's basically Google's hosted version of Kubernetes. And so that automatically plugs into their storage, to their load balancing, to their networking. And then additionally, they have a portal on top of it, easy access to the command line. So when I talk about like a complete container platform, you have to go one step beyond kind of that, just the application framework, like the schedulers/orchestrator that you're using.
What are some of the problems that a container platform will solve?
I mean, a lot of them is dealing with it's how do you scale your application? How does your application handle failure? And then how does your application talk to each other? So, I mean, these application are, these frameworks and container schedulers and everything, they're really oriented towards microservices. That's where they really shine. So they're going to allow you to deploy an application that's going to horizontally scale, but then you can have multiple microservices and be able to easily talk between those. So I think that's where things like service discovery come in, the automatic networking, network policies for security. So it really handles that, the intercommunication, scaling, and then how to handle failure. So, if you have like health checks, if your container goes down or your application, how do you reschedule it? Where do you, what do you do about that?
One of the advantages of these containers and then container platforms is that they provide an abstraction that improves the portability story for our applications, even our distributed applications. And I think Rancher is an example of this because Rancher can run containers consistently on any infrastructure. I think that's probably the case with a lot of these different platforms. Do we need an additional layer of this container platform to give us even more portability? Because I thought that the whole story for containers was that containers themselves can consistently run on any infrastructure. Do we get additional portability advantages from a container platform?
Yeah, you do. And so that has to do with so there's kind of two layers of looking at this. It's like from an end user perspective, like I'm just the guy, I'm the developer, I'm writing an app, I'm deploying it. If I'm deploying to, Kubernetes or Swarm, from the application developer's perspective, that's portable. That's going to run anywhere that you can get Swarm or Kubernetes or Mesos. The problem with the portability is that next layer of like, okay, I actually want to run Kubernetes. If I want to deploy Kubernetes, you look at the docs that are available, and they'll say running Kubernetes on AWS, on GCE, on bare metal, and there's a different approach for each one. And so that's kind of where you start losing the portability, is in the actual deployment maintenance of the frameworks itself that you're running. And that's kind of the problem that Rancher tries to solve, is we make even that layer portable. So from, kind of like your DevOps ops perspective, the stack that you're deploying so that your application developers can deploy on, that stack can be run anywhere. So you can really completely abstract yourself from the what infrastructure, if it's bare metal, if it's Amazon, if it's Google, Azure, whatever it might be.
Or heterogeneous infrastructure too.
Yeah, exactly. And then also, you add into that Windows and Linux, now that Windows is, really, they're really upping their game on containers here. So, that adds yet another kind of factor into this.
So if I were to roll my own container platform story, and let's say I've got some infrastructure where I've got some EC2 instances, I've got some Windows machines that are on premise, I've got some Rackspace cloud instances, and on each of these I'm running some Docker containers, and I want to network these Docker containers together, and I'm not using a container platform. What are the problems and the inconsistencies that I might encounter, especially if I try to unify these different pieces of compute, and I try to just treat them all as the same sort of thing?
Sure. Yeah. I mean, this really pops up when you start looking at networking. So, let's say if I started in Amazon, the obvious thing to do would be, okay, let me just start doing all my networking based on VPC. And, there's a lot of things you can do with VPC with adding routes. And so if you go and you build all your networking around Amazon, now it's like, okay, now I want to extend into, let's say, Rackspace, or I have my own, on-premise bare metal thing. Then you're going to be looking at like a VPN gateway, then doing the routing and all of that. So, you start looking at every cloud that you add, you have to take into account, like, how am I going to get the networking to work on that cloud? So you really have to take a step back and say, okay, what if instead of using like the infrastructure providers, native capabilities, what if I use, something that works at a higher level? And that's where you get into where all these, networking solutions are today. Rancher out of the box, we provide IPsec-based networking, but there's other great projects like Weave or Calico that will do this. And so instead of, let's say, using VPCs, you just stick with a very simple flat model in Amazon. Don't take advantage of any of their features like security groups. And then you just run something like Calico, do all the network policies through that. Then immediately that software is going to work everywhere. So you don't have to consider, the differences between each cloud. And this is, to me, this is one of like the fundamental differences that we're seeing with containers than we had with virtual machines. With virtual machines, there was always this story of hybrid cloud. But what it ended up being is that each cloud you added required a significant effort because you had to, basically do all this integration work. With containers, since we're kind of moving up the stack a little bit of focusing really on like Linux or software, or basically the operating system layer, we can just look at portable software. And so if we just start at that layer and say, okay, if I have portable software that can run anywhere, then I don't have to care about my infrastructure provider anymore. And it's by default portable.
Okay, so let's talk a little bit more about Rancher specifically as an example of a container platform. And maybe throughout our conversation, you can illuminate how Rancher might differ from other container platforms out there. So the Rancher platform manages your hosts and the Docker containers within that host. What does management actually mean in this context?
Yeah, so it kind of depends on which flavor of kind of Rancher you're using. So for most people, it starts with, what's going to be my application orchestrator. So right now we support Docker Swarm, like the brand new Docker Swarm that will be released soon. That will be supported in Rancher. We also have the old Swarm support. But then additionally, Kubernetes, Mesos, and then we have our own framework called Cattle that's been around for a while. So it kind of first starts with how are you going to deploy your applications. So like, for example, there's a lot of interest these days in Kubernetes. So if you pick Kubernetes, okay, you say, okay, I'm going to deploy my application with Kubernetes. Now, once you have that, what Rancher is going to do on top of that is then add the management of the storage, networking, security, access control. And then we have a feature which is called Catalog, which is basically for managing applications. So you can kind of, a developer can bundle up their application to kind of into a singular unit. Like it might be a series of microservices, but it's a singular unit, and they can just click install, manage upgrades, and it's a full kind of management of that integrated through like Git and GitHub. So it kind of gives you a good story around lifecycle management of the applications and how to control that, who can do what.
So one thing you're saying here is that Rancher offers some swappability for different schedulers. Like if you want to use Kubernetes, you can use that. If you want to use Docker Swarm, you can use that. Why would people choose different schedulers?
Right. It's kind of, each one has its like strengths and weaknesses. And so kind of depending on where people are in their maturity with containers, what's their primary use case, we see people picking or gravitating towards different ones. To be perfectly honest, all of these frameworks are kind of converging to the same basic concepts. So honestly, over time, probably in year or so, I don't think there's going to be a fundamental difference between them. But right now there are some kind of clear differences. Just between the different frameworks that we support. Mesos is really great at getting better resource utilization out of your hardware in terms of if you're running a lot of big data stuff. Like that's really their sweet spot is big data. So we see, if you're doing things like Spark or Hadoop, we see a lot of people gravitate towards Mesos. Kubernetes is really great at running web scale applications. The concepts are extremely well thought out. They come from a lot of experience at Google. So, if you're really looking at larger scale applications and, really getting to this model of, you don't care about your where it's running or, it's kind of like the pets versus cattle thing. You're moving more towards that cattle model. Kubernetes is great for that. The kind of the downside of Kubernetes is it is relatively difficult to get into it. The concepts are really complicated at first. It takes a while to learn it. So, and then the last one is Swarm, and Swarm is kind of, that one is still emerging because it technically hasn't even been released yet. So it's kind of yet to be seen exactly where that framework is heading. But historically, kind of where Swarm has done really well is within CI, because it's very simple to get up and running. It's very simple to integrate, and there's not a lot of thought about like how to scale my application and do all these things. It's just kind of it's very simple. I want to run a container, and so it's fit into CI really well.
When you talk about a platform, a container platform like Rancher being integrated with one of these schedulers, does that mean that I'm interfacing with these schedulers through Rancher? Like, am I just using the Rancher command line to interact with these schedulers, or am I actually using the command line tools of the scheduler?
Yeah, so you're using the command line tool of the scheduler. So like from a Rancher perspective, you can look at we're kind of integrating a lot of things and pulling it together, but we don't really want to get in the way of the end user. It's like you picked Kubernetes for some reason. You want to use Kubernetes. We don't want to we don't try to provide some like normalized experience across these or, because they all have their strengths and weaknesses. We look at it more from the perspective of it doesn't really matter which scheduler you're going to deploy. You're really going to run into the same types of issues and gaps to really get this to work within an enterprise. So, the schedule is just one aspect of it. There's a lot more that you need for the kind of the complete end-to-end solution.
For example, monitoring tools, registries. So do you write code that allows Rancher to integrate with all these tools? So let's say I want to use Prometheus as a monitoring tool over my Kubernetes scheduled cluster. Maybe if I didn't have a container platform like Rancher, I would have to do some complex integration, but Rancher gives me more of a plug-and-play glue.
Yeah, exactly. It's kind of like, choose your own adventures with containers. You go in and you say, okay, I want Kubernetes. Now, what do I want for networking? Basically we have a out-of-the-box solution for all of these categories, but we know people, want the flexibility to run other things. So for networking, maybe I want Calico because I like their policy-based stuff. Then for monitoring, I want Prometheus. And then for storage, I might just want to use EBS. So for each one of these things, that's where kind of our catalog comes in into the picture. Is you can go to our catalog that we have, and there's a lot of the software is already packaged up, and you can just click and it'll deploy and run, and you don't have to give a lot of thought of how to integrate or whatever.
How do you manage that? Because this is a rapidly expanding ecosystem. If you have to write integrations for all of these things that are being built, it sounds like a lot of work. How do you manage that?
Sure. Well, there's two technical things. Like one is like, how do we actually get that to work? Like, what's the technology managing it? And then how do we integrate with the various, the infinite number of combinations and everything? So the first thing is when I mentioned that, the different schedulers that we have, one of them is Cattle, which is our own our own framework. And that's actually the thing that runs under the hood to schedule a lot of the infrastructure level stuff. Because let's say if I'm deploying networking, I'm not exactly going to use Kubernetes to deploy its own network management. It's kind of a chicken and egg thing, and also causes a little bit of problems with availability and whatnot. So Cattle is our very low level infrastructure oriented, scheduling framework. And so we're actually packaging up all of these softwares as Docker containers and deploying them with our own frameworks called Cattle. Now, once we deploy that software, it has to integrate with the various platforms. And there's kind of two ways that we're doing that. One is, the nice thing is all these things are built off of Docker. So there's a lot of commonality between them. So if I deploy, let's say, Prometheus in a Swarm environment or a Docker or a Kubernetes environment, you still get that kind of base level visibility of like, here's a bunch of Docker containers. Now, then there's the next level of integration, which is, I actually want like Prometheus to know about Kubernetes specific concepts. And those are largely being handled by the communities themselves that are producing these software. So we're not actually having to do a lot of this. We just pretty much have to configure it. So a lot of them is being handled by the community. The other kind of part of this is like when you look at storage and networking is we're actually starting to get towards, better standards. And so networking, for example, is really gravitating towards CNI. So I can actually deploy CNI and so I can deploy, like say if I do Calico with CNI, that will work with Kubernetes, that will work with Mesos, and then we have support to make it work with Docker too. So we're kind of banking on the fact that, as things move forward, there'll be a lot more standardization. And we're seeing that. This is why we're members, like us personally, we're members of CNCF and OCI. Because we very much care about these kind of standard integration points, so we can have more pluggability between these frameworks and tools.
Yeah. So speaking of that standardization, there's a different kind of standardization that Rancher also has built into the platform, and I'm curious about this more generally too. So you have the Rancher OS, which is a minimalist OS that's built explicitly to run Docker containers. So what is Rancher OS?
Yeah. So that's a great question. Because honestly, this even confuses a lot of our users and people coming into Rancher. It kind of depends on how you first heard about us, because we have two separate products. One is Rancher, which is the container management platform. And then there's Rancher OS, which is the minimalistic container operating system. And those are two completely separate products. One doesn't require the other. So that's just something, kind of want to get out of the way. But Rancher OS, basically what it is it's a minimalistic Linux distribution that everything's a container. It's 100% a container. And the idea of this came from basically, we started to build Rancher, the management platform, and really all we need is a Docker daemon. Like, we don't care very much about the host operating system. We just needed a Docker daemon. And so we started to experiment with, what's the smallest possible thing I could do to get, Docker running. So it's kind of like boot to Docker, but even like, how do we turn boot to Docker, I guess, basically into like more of a production ready thing. But what we wanted to do was, we didn't want to build just yet another Linux distribution, use kind of standard approach like RPM, Debian packages, whatever. We just wanted everything 100% to be a container. And at the time we started this, it was really, really, really pushing the envelope of what you could run in a container. And the great thing that's come out of this is kind of all the hacks and things that we figured out of how to run things like UDEB in a container have basically all been upstreamed into Docker now, such that, basically you can run pretty much any software in a container. It's not going to be well contained maybe, but you can still get it to run. And so a lot of people ask, like, what's like the fundamental difference between, let's say, CoreOS and Rancher? Or Rancher OS, sorry. Yeah. I don't know if you want to ask the question or...
no, please just answer it.
Yeah. So this is one we get a lot. And honestly, I love CoreOS. I was a very early user of CoreOS. Those guys do some great thing, really pushing the envelope there. And so when you look at CoreOS, the core thing about CoreOS is actually, their tagline has always been securing the internet. And so the main thing about CoreOS is that the operating system is delivered as a single image that's like signed and secure and all that. But if you look at what CoreOS is, it's still basically a standard Linux distribution. It's based off of Gentoo. It runs systemd. There's really nothing, kind of fundamentally different about how it is. It's how the operating system actually is. Like their key innovation is how it's packaged and delivered as an image. What we did with Rancher OS was we actually wanted to kind of go a couple steps further and say, let's completely change how we look at a Linux distribution and let's package everything 100% as containers. And so this is something that's kind of hard for a lot of people to grasp because they'll say like, well, what's like the host, like what's actually running on the host? And to be honest, what's on the host is like 4 files. It's the Docker daemon, like that binary, I think like mob probe IP tables and kernel modules, and that's pretty much all that's on the host. And then everything after that is a container. And so the fundamental difference is, we're just pushing it to that level of, everything is a container, and we just look at it, from that level.
And now, do I have to use Rancher OS if I'm using Rancher?
Yeah, that's not required. So I would say the vast majority of our users are either on Rails CentOS or Ubuntu. So it kind of depends if it's enterprise, Rails is obviously the king there. And then in the open source world, Ubuntu is more popular.
I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month, so my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. So I'd like to talk about Rancher in a little more technical depth. So Rancher, the platform itself, has 2 main components, and the first is the infrastructure backplane. What is an infrastructure backplane?
Yeah, that's where we just basically look at managing kind of the core resources of hosts, storage, and networking. That's kind of when you look at, the 3 tenets are compute, storage, networking. So how do I get those 3 things to be able to, run my infrastructure? And so that's really what we say is kind of like the infrastructure backplane, is getting those things in place. And so, the difference is like Rancher is going to give you a completely cloud agnostic, infrastructure agnostic backplane, as opposed to like if you just go like directly to, let's say, Amazon or Google, they're going to give you like, those specific technologies like EBS or VPC, which are going to be, essentially lock you into that cloud.
Mm-hmm. And on top of this infrastructure backplane, a Rancher deployment uses an application service for managing Docker containers. And I think the application services, this is basically another word for schedulers. Is that right?
Yeah. So, I mean, it's, so that when you get up into the services layer is then when you get kind of the variability of which one you want to choose. So, if you go with like the cattle experience, which is our own thing, then it's something that looks very similar to Docker Compose. If you go with Kubernetes, then it's going to be like Kubernetes services, replication controllers, and pods and those things. Or if it's Mesos, you'll be deploying tasks or Marathon.
Okay, and regardless of what scheduler I'm using, I'm going to need to do some software-defined networking, which if somebody is very familiar with Docker and this container environment, they probably know what software-defined networking is. But maybe for people who are a little newer to this area, why don't you give us a definition for software-defined networking, and then we can have a little bit of a discussion around it.
Oh, shoot, that's a hard one. Because it's a very loose term, what software-defined networking is. And it's just basically, instead of interacting directly with your switches or routers or kind of the legacy networking equipment that exists, software-defined networking is controlling everything, at a layer above that, which, is just controlled by some type of management plane. So you don't have to basically go to each individual device and program it and set it up.
And so what does that mean in the context of a container platform?
Yeah, so for a container platform, it's basically, it's really interesting because, my background is actually, I came, first from more like hosting, then infrastructure as a service, like VMs and things like that. And in that world, you spend a lot of time talking about networking and how to set it up and VLANs and switches and all that stuff. Now, when we move to this container world, there's actually a lot less discussion of networking. People care just more about, can my apps talk to each other? Is it secure and private? And so that's basically what SDN is going to give you in a container world, is that you just really don't have to think about a lot of that. It's like I deploy these two containers, these services, and I want them to be talk to each other, and it just kind of magically happens. And there's a lot going on under the hood to make that happen, because you have containers that have IPs on each host, and that has to be either attached to the underlying fabric or run over an overlay network, somehow encrypted if you need that. So there's a lot going on under the hood. But from a user perspective, it's to be honest, it's just somewhat magical. It's just that's the idea, is it should just work.
So let's say I want to use software-defined networking in order to set up some service discovery and orchestration using Rancher. What exactly do I need to know in terms? So for a given container platform, we could use Rancher as an example. What do I need to do to get service discovery and orchestration so that it's running smoothly, so that my developers can easily just stand up a service and it's as effortless as possible?
Yeah. So, specifically with the networking, so there's two things there. You have the networking and then the service discovery, and those kind of are separate topics. So the base networking, if you're just kind of doing this yourself, then you're going to basically, look at what's out there. So there's a lot of guides. I think, Kubernetes is kind of the most complete in terms of like documentation and whatnot in setting these things up. And so they'll kind of tell you, if you want to run this on Amazon, here's how you do it on Amazon. If you want to use Flannel, here's the instructions for Flannel or Calico. So it's kind of, if you're going to do this yourself, I think the first approach is, the first thing is, what's the right SDN solution for me? Should I pick, what is my infrastructure provider provides? So, am I going to use like GCE directly or AWS directly, or should I go with, something that's cloud agnostic, portable, so Flannel or Calico, or Weave. So each one of those has, a different kind of strength and weakness to them. So once you get those figured out, like, which one you want, then you kind of go through the steps of plugging that in. And so there's, first I get Weave running. Now, how do I get Weave to work with Mesos? How do I get Weave to work with Kubernetes, whatever, application framework you're using there? So, once you pick the technology, then you actually get it deployed. Then you figure out how to integrate it, with the schedulers.
And in what ways does a container platform help me out with that?
Yeah, and so that's the idea, is that like basically you just don't really have to think about it. So when you go to a container platform, there's going to be either like in the case of Rancher, we give you a choice. In the case of like something like GKE, there's not really a choice so much. They just give you what's built in. So the idea is, if you don't know anything about networking, you don't want to think about that, you don't have to. So it's like if you go with the choice of using like Rancher, you just basically start running and we have our default networking. But if you come into certain requirements where it's like, I need more advanced policies, then you might start looking at Calico. So that's what basically the container platform is going to do for you, is if you don't want to think about that aspect, you really don't have to.
So let's talk about DNS, for example. So let's say I've booted up Rancher, I've got it going, and it's using the native DNS functionality for Rancher. And if I wanted to switch to Weave DNS, for example, how would I do that? And what's going on under the covers when I swap out the DNS plugin that I'm using?
Yeah, so DNS is kind of a tricky one, because at this point, DNS is being kind of really heavily pulled into the schedulers, like the new Swarm kit that they've announced has basically a built-in DNS server. They had it in like Docker 1.11 also, but it's kind of a core functionality. And then GKE has a Sky DNS, or they have a specific way of doing DNS. So the problem with swapping DNS stuff right now is that the model and how DNS is being used ends up being somewhat specific to the framework. But it is possible. Instead, if you I don't want to use the Kubernetes way of using DNS or the Swarm way of using DNS, you can, in both those frameworks, for example, flip them off, turn them off, and then deploy, let's say Weave DNS. So in those situations, so then it'd just be a matter of, turning it off in those individual providers and then deploying, Weave DNS or something.
Okay, so let's talk about adoption and usability. How does a typical customer, if I'm a typical customer, I've got my application running on, let's say, on Amazon EC2, I've just got some Rails monoliths that are scaled, or maybe that's a bad example. I've got some microservices infrastructure. Let's say I'm Netflix or something, and I want to onboard with Rancher. How do I migrate my decoupled microservices infrastructure to a container platform like Rancher?
Right. So it kind of depends on where you are in your your adoption of containers. Typically, what we come into is people have basically just started containerizing their applications. So they've got it such that they've containerized it, so the app is running in a container, but they're most likely using their old way of deploying. So either it's manual, like Puppet and Chef, they're using some configuration management framework. So that's typically where Rancher would come in, is people are at that level. So then the next step is basically, okay, well, how do I actually describe my application in some templatized format, which would be, if it's Kubernetes, like services and replication controllers. If it's Docker or Cattle or Swarm, it would be a Docker Compose format. So basically, you would start looking at describing your application in a template. And then for the most part, Rancher itself is super easy just to get up and running. So, it's just a Docker container in itself. So you just launch that, and once you have your app in the templatized format, then, you start deploying it either through the web interface or through our command line. So the onboarding process, at least from a Rancher perspective, is very, very simple. We don't, that's at least been the one good thing for us, is we've had just good organic adoption. People come, kind of gravitate towards Rancher just because it is so simple to get up and running and get going.
What about the continuous deployment story? How does continuous deployment for me change when I move to a container platform?
Yeah, to be honest, I think it's relatively difficult to be doing continuous deployment if you're not using a container platform, because the problem is when you run into microservices is if I just have a singular unit, it's relatively easy to do continuous deployment. It's just deploy this new thing. It's when I start having an application that's distributed, and there's more components, and so it's kind of this larger picture that's where the platform can help you with. Because let's say I've described my app as 5 different microservices that are all talking to each other. If I push an update in just one of those changes, then I need to be able to just deploy that, upgrade or deploy that one thing. But there might be, it's like, how do you do that in a seamless way without not having downtime and whatnot? And that's what these, these full container platforms and solutions will do for you is how do you, do a rolling upgrade? How do you manage the, load balancing to that application, or draining sessions and discovery? Like if you want to do a blue-green deployment. So there's all these different, ways, because there's not like one strategy that fits all. Like it kind of depends on your application and how it behaves, of how it's going to be upgraded and deployed. And then so, to be able to do this efficiently, I really think you have to pull in one, a full container solution.
What about monitoring? How does a container platform assist me with the monitoring story?
I know from a Rancher perspective, it's largely, so we can deploy the monitoring solution, but it's kind of like providing the additional metadata to tie everything together. Without the container platform, basically you're just going to see a bunch of containers. Like I've got 100 hosts and I got 1,000 containers. Like what are those things? Like how do they associate to each other? So there's the monitoring systems, but being able to feed the monitoring systems the additional metadata such that they can show a more application view, and more of a relationship. And that's kind of what really helps you out there is, instead of looking at these individual entities, I can actually see them as applications and scaling groups and things like that. And so you can do better, kind of root cause analysis and, what's going on, with that additional metadata.
Okay, let's talk a little bit about the business model for Rancher and this broader ecosystem. How does Rancher make money?
Yeah, it's pretty simple. We focus on basically support. We sell support, licenses for Rancher, and so everything we do is 100% open source. That's worked extremely well for us. There's 4 co-founders of Rancher. 3 of them previously did Cloud.com, which was also a company that was completely open source. So we're really familiar with the open source model. We really like it. It works well for us. And so our focus is really just on selling support for Rancher.
The objective is Docker as a service. So why? I don't mean to sound like hostile here. Why would Docker as a service be easier for Rancher to do than Docker, the company itself?
Yeah, so that's a great question. So if you look at Rancher, when we talk about, what's a container management platform and why do you need it? It's like if you look at the Docker solution, so you have Docker Swarm, and then on top of that you have UCP. So UCP is kind of the product that is more on level of what Rancher is doing. So we're very, very similar products. But so the difference between basically what we're doing at Rancher and what Docker, why, you might say, we would be a better approach is we really look at the larger container ecosystem, not just Docker. Like Docker is not just, there's more to containers than just Docker. Docker is one approach. So if you go and you get UCP, basically you're going to get the Docker Swarm solution. And what we've seen as we've gone into companies, especially very large organization, is you don't have that consistency across the whole organization where they're just going to pick one framework. like you already have an investment in Mesos, for example, and then you're looking at Kubernetes, or there's other frameworks that are popping up, like Nomad, which was just last year or so. Habitat was just released. These frameworks keep popping up, and they all have their pros and cons. I don't really think there's going to be a clear winner. Like, it's not a zero-sum game here. So the difference kind of between Docker and Rancher is that I feel like we really look at a larger container ecosystem, and we're very much, somewhat kind of the Switzerland of containers, and that we really don't have a specific preference. There's pros and cons of all these technologies. We're just going to help you bring them all together and run them. So, we're going to help you run Kubernetes if you want Kubernetes, or if it's Swarm, then Swarm's fine, or Mesos, or whatever new frameworks pop up.
Okay, interesting. So I was going to ask about the Red Hat OpenShift, how Red Hat OpenShift compared to Rancher, but it sounds like there's a pretty big obvious differentiator there in that Red Hat OpenShift is explicitly built on Kubernetes, where Rancher has some more swappability at the scheduler layer.
Yeah, and that's what you're going to see is just really what's fundamentally different between Rancher and the rest of the guys is just the flexibility that we provide, that we can pick. You can have different solutions, and as we go and we talk to people in the enterprise, people are very, very concerned about lock-in. That's just they very much want to make sure that they're not stuck with one technology. So we provide that.
To close off, what are some tips that you have for people who want to run containers in production?
That's a great. Really, what it comes down to, is looking at what's the state in your application. If you can properly isolate and manage the state of your application, then it becomes significantly easier to run it in containers. Containers can actually run stateful workloads. You just need to be able to identify it and be able to manage that in a stateful fashion. But then if you can really keep the state centralized to a couple different components, then it's significantly easier to manage the applications at scale. It makes everything just drastically easier. So that would kind of be the biggest thing that I see for people is just really look at how they're managing state.
Okay, well, Darren, thanks for coming on the show. This has been a great conversation about container platforms.
Yeah, thanks. I really enjoyed this.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks again, Symphono.